Hello, and I'm John Rutger. We're going to get started on this problem right away from section 1.5, number 25. The problem reads as this, and we have to worry about that later. I'm going to get started right away. Let's get this into dy dx plus p of x y equals q of x. So we're going to get dy over dx plus 3x to the third over x squared plus 1 y equals 6x x squared plus 1 e to the negative 3 over 2x squared. We need to find the integral of our p of x, so integral of 3x to the third. I'm actually just going to rewrite this right away. Take out our constant 3, and it's going to be x times x squared over x squared plus 1. You're going to see why I did this in a little bit. Our u is going to be u is our x squared plus 1. Let's take that 1, minus it. So u minus 1 equals x squared. And our du will just equal, it's going to be 2x. But let's just make it x dx because that's all we have. And our du over 2. So let's put our u in for our u substitution. We're going to get 3 and pull out our constant right away. Over, and then let's do our integral. After looking at this for a while, you hopefully should see that you're doing 1 over u times u minus 1 du. Simplifying that down, we're going to have 3 over 2, the integral of 1 minus 1 over u du. That's pretty simple. In the end, we're going to have 3 over 2 times u minus the natural log of u. We're not going to do plus c here, since this is going to be, you can read it in the book, there's some literature on it. Just going to keep on going. Okay, taking in and putting our x squared plus 1 for u, so we're going to have our 3 over 2 x squared plus 1 and our minus 3 over 2, the natural log of x squared plus 1. Right away, we can put that to our e, and now we have our row right here. We're looking at this. We can see that we have 2 parts to our row, and actually this one will cancel. We're going to put our negative 3 over 2 up here, if you don't know why. You can look it up, Google it. So we're going to eliminate those 2. We'll have, now our row has changed to our x squared plus 1 to the negative 3 over 2 e to the 3 over 2 x squared plus 1. Okay, now we need to put our row right away into our equation. The worst part about writing on a whiteboard is the erase time. That's what takes most of the time. Okay, so we have to put our row in. I'm going to do the left side first, and then I'll do the right side. X squared plus 1 to negative 3 over 2 e to the 3 over 2 x squared plus 3 over 2. It's not that necessary right now, but you'll see why later. dy over dx plus 3x to the third over x squared plus 1, multiplied now by our row, x squared plus 1 to the negative 3 over 2 e to the 3 over 2 x squared plus 3 over 2 y. And you can't see it now, but this is really negative 2 over 2. Add that to there, so we'll have 3x to the third multiplied by x squared plus 1 to negative 5 over 2, and our e to the 3 over 2 x squared plus 3 over 2 y. This is actually the derivative of this, and this is waiting to be derived, and it has our y right there, so let's just combine it. Combining like terms, this can really be wrote as d over dx of y times x squared plus 1 to the negative 3 over 2 e to the 3 over 2 x squared plus 3 over 2. That's our left side. So let's go back and let's find our right side. Lots of fun, lots of fun. Okay, so let's see, we have 6x over x squared plus 1 times e to the negative 3 over 2 x squared multiplied by x squared plus 1, negative 3 over 2, e to the 3 over 2 x squared plus 3 over 2. So we can actually eliminate this now. We have this, these eliminate. We can combine these like we did on the other one. So this was going to be 6x times x squared plus 1 to the negative 5 over 2 e to the 3 over 2. We're going to have to take the derivative of this since we have it down here. So I'm going to rewrite this right down here. Actually, we don't need to rewrite this. We're going to take the derivative now of this to finish off our right side and take this over to simplify it down. So I'm going to make more room for this. We don't need our row anymore. So let's find the integral of, see, we'll take out our 6e to the 3 over 2. Put that over here. We'll have x times x squared plus 1 to the negative 5 over 2 dx. Let's do u substitution again. Our u is going to be x squared plus 1, and our du will equal 2x. Remember, we're going to take that dx over here divided by that 2. We're going to have, in the end, for our u, we'll just have u to the negative 5 over 2 over 2. This actually, after plus 1, will be negative 3 over 2. Dividing by negative 3 over 2 is actually taking it times negative 2 over 3. Our negative 2's will cancel. We'll have a negative, in the end, we'll have negative 1 over 3 times u to the 3 over 2. This is going to have plus c on it. So putting that back in, let's put it our x squared plus 1. So we're going to have negative 3 x squared plus 1 to the negative 3 over 2 plus c, and times our constants, 6e to the 3 over 2. Remember that when you're timesing constants on a constant, our c will remain the same. So in the end, this will just be 1 over 3. I was getting ahead of myself because this actually will cancel off and make it 2. For our right side, before we go to simplification, it's going to be negative 2e to the, to the 3 over 2 times our x squared plus 1 to the negative 3 over 2 plus c. So now we're going to go back, and now that we have this simplified, we're going to have to do a lot more work to get from the equation we had before still. So we have, now we have our y times x squared plus 1 to the negative 3 over 2 times e to the 3 over 2 x squared plus 3 over 2, which is equal to now negative 2e to the 3 over 2 times our x squared plus 1 to the negative 3 over 2 plus c. Now we're gonna get rid of these by multiplying by the opposites, reciprocals. So x squared plus 1 to the 3 over 2 e to the negative 3 over 2 x squared minus 3 over 2. That's the opposite. That will cancel these out. This, since these have x's in them, have to be kept when we multiply this by our c. But some of these are canceled. So like here we can see, again, the property where this is actually separate. We can eliminate that. This will eliminate this. We'll have y equals negative 2. And all we're going to have left on this side, since we eliminated this with that, and half of this, we'll still have the e to the negative 3 over 2 x squared. So that's what we're going to write here. We have negative 3 over 2 x squared. And now we're going to find what we have for our c. So we have plus c, and we're going to have to keep all of this. So x squared plus 1 to the 3 over 2 e to the negative 3 over 2 x squared minus 3 over 2. And you're going to want to keep that like that, because now we have our foundation equation. Now we're going to try to find y of 0 equals 1. So we know that we're going to put our x's in for 0, and that's going to be equal to 1. So 1 is going to equal, well, right here, this is e to the 0. That's going to be negative 2 plus our c. This right here, this is going to end up being 1 to the 3 over 2. So this is going to be 1. That's nothing. So I'll just get rid of that to make this easier. And then this is going to be 0, but we have e left to the negative 3 over 2. So 3 plus negative 2 equals 1. How are we going to get that? So our c has to equal 3, but then we have to get rid of that e by being 3 over 2. Now, remember our c, and I'm going to go back real quick and try to put that back into our equation here. So we'll have y equals now negative 2e to negative 3 over 2 x squared plus e, or 3e to 3 over 2 times x squared plus 1 times 3 over 2 e to negative 3 over 2 x squared minus 3 over 2. Let's see, this negative, so we can cancel this off with this. Then now we see that we have all that's left is our 3x squared plus 1 and our negative 3x squared here and our negative 3 over 2 x squared here. So we can just combine these. This is literally the last part of the equation. So our y of x will equal e to the negative 3 over 2 x squared. 3 times x squared plus 1 to the 3 over 2 minus 2. There we go. That is our answer. That's the final. That's all we need. Done. Thank you for watching.